Okay, today we have a very short lesson on solving systems of nonlinear equations. If you remember last time, we solved systems of linear equations. Now, they don't have to all be linear equations. We can still solve it the same ways as before. We can use graphing, substitution, or elimination. Now, because we can use Desmos on our tests and on our homework, the easiest method and probably the only method that we're going to be using in class is graphing. So let's just go over a couple of examples of graphing so you can do it pen and paper, and then the rest Desmos will do for you. Okay, so to solve these by graphing, we're going to do the exact same as we did for linear. We're going to graph both functions and see where they overlap. Okay, looking at this first equation, x squared plus 6x plus 4, how do we graph? Well, first, we need to find the x-coordinate of our vertex. And how we do that is we do negative b over 2a, or in our case, our b is going to be 6, and our a is going to be 1. So we can say negative 6 over 2 times 1, which simplifies to negative 3. So that is the x-coordinate for our vertex. Now to find the y-coordinate for a vertex, we're just going to take negative 3 and plug it into this equation. So our y is going to be equal to negative 3 squared plus 6 times negative 3 plus 4. Now, if I figure out what negative 3 squared plus 6 times negative 3 plus 4 is, it comes out to be negative 5. Okay, so now we have an x and a y. That's our vertex. It's going to look like negative 3 comma negative 5. That's our vertex. So now I'm going to go down to my vertex and put my first point. So go over 1, 2, 3, and down 5. 1, 2, 3, 4, 5. So there's the first point. And now if you remember from our quadratics unit about our growth pattern, it's 1, 3, 5. So we go over 1, up 1 on both sides, over another one, up 3 on both sides, and then over one more, up 5. 1, 2, 3, 4, 5. And just like that, we've got our basic shape of what our quadratic's going to look like. So we can then come through and graph that like so. And then to graph our second equation, we just want to put this into slope-intercept form. That's going to be when y is all by itself, so I'll move that 2x over to the other side. So y is equal to negative 2x minus 8. And to solve this, I'll do my y-intercept, which is negative 8. 1, 2, 3, 4, 5, 6, 7, 8, right here. And then my slope is negative 2, so down 2 to the right 1. Or I can back it up, go up 2 to the left 1, up 2 to the left 1, and so on. And then once I've got enough points that I feel confident, I can draw that line just like that. Now I would like to see where these two graphs overlap or where they intersect. And it looks to me like they intersect right here and they intersect right here. If I look at those 2 points and I figure out where they are, the first one is at negative 2 comma negative 4, and the second one is at negative 6 positive 4. And that would be the solution to my system of nonlinear equations. So now I have 2 answers instead of 1 answer because I don't just have lines, I have some quadratics mixed in here. Okay, now let's do example 2. Looking at this first equation, it's just the standard quadratic centered at the origin. So my first point will be at 0, 0, and then I'll do my growth pattern. It's 1, 3, and 5. I'll copy that to the other side here. That's the basic form of my quadratic. So now I can draw that out. Whoops, let me retry that. Okay, we'll pretend like that's a straight line. And now we'll do our second one. So we've got y equals 8 minus x squared. If I put that in the more standard form we're used to, it would look like y equals negative x squared plus 8. What this plus 8 here does is shifts my graph up 8 units. And what this negative does is instead of opening up, it'll open down. So my origin is going to be 8 units up. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'll continue my growth pattern, but I'll do it downwards because of that negative. So I'll go 1, and then I'll go 3, and then I'll go 5. And now that I have that, I can draw my quadratic like this and like that. Okay, so where do they overlap? They overlap right here and right here. So my solutions to this would be negative 2, 4, and 2, 4. And that would be my solutions there. Now in reality, we're all just going to copy those equations and paste them into Desmos. We'll look for where they overlap, and that will be our solution. So we're actually not going to practice any substitution or elimination today. That's the end of notes. Don't forget to do the Delta Math online.